This is topic 4-3, functions revisited. So when this one says find the domain in the range of the relation, then determine if the relationship is a function or not. So when I'm looking for domain, I'm looking at all my x's. And I'm going to list them in set notation. And I'm going to list them from least to greatest. And then my range is all my appropriate values of y. And again, I'm going to list them in set notation. And I'm going to list them from least to greatest. Now when I'm looking at whether it's a function or not, I'm going to just pay attention to my x's. And if my x's repeat, then it is not a function. And right here, when x's is 1 and 1, this would be not a function, so no. And why isn't it? Because x equals 1 repeats. If it repeats, it is not a function. Okay, now we're going to have a couple of functions and we're going to have to evaluate and find the following. So f of -3. F of -3, we're plugging into x squared plus 4x. So f of -3 equals, make sure you put your negative in parentheses, -3 squared is 9. Positive 4 times the -3 is 12, which this would be -3. G of -5, make sure you're putting it into the G function. So G of -5 equals 5 minus 3x equals 5 minus 3 times a -5, which is 5 minus 3 times -5 is -15. This is keep, change, flip, which is 20. On this one, you're going to do f of 1 and g of 3. So f of 1 is x squared plus 4x. Plus g of 3 is 5 minus 3x. Now these x's mean different things because they're the different functions. 1 squared plus 4 times 1, I'm going to run that through. 1 plus 4, which is 5. Then I'm going to do 5 minus 3 times 3, 5 minus 9, -4, a 5, and a -4 equals 1. Here we are doing f of -2 minus g of 4. I'm doing x squared plus 4x. I'm going to do -2 squared plus 4 times -2, 4, and a positive 4 times a -2 is a -8, which is a -4. Then I'm going to do 5 minus 3x, 5 minus 3 times 4, 5 minus 12 is a -7. So I have a minus, which is this minus right here, and then I have a -7. This is keep, change, flip. So this final answer is 3, a positive 3. I'm going to write the functions next to it so I don't have to keep scrolling up. F of x equals x squared plus 4x. G of x equals 5 minus 3x. So I'm going to do, it is working inside out. So I'm going to multiply 2 times g of x, which is, make sure it's the g of x. We're doing this one first now. 5 minus 3 times 2. And then we're going to add it to 3 times, and now we're doing f of x, which is 2 squared plus 4 times 2, which is 2, 5 minus 6, plus 3, 2 squared is 4, 4 times 2 is 8. Then I'm doing, negative 2. Missed my negative, be careful. Which makes that a negative 6, which that's keep, change, flip. So that becomes 2 times 11. Plus, it's really easy to drop your negatives on these problems, especially when they get lengthy, so please be careful. 3 and 12, 3 times 12, 22 plus 36, for a grand total of 58. Okay, the next question is, we're going to the graph and we're going to list your points. When you list your points, what I would do is I would label them. It'll help you a little bit with this being A, B, C, D, E, F, and G. And then you can go ahead and list them up here. A is -3, 4, which means 3 to the left and 4 up. B is -2, 2 to the left and 5 down. C is this point right here, which is on the y-axis. Didn't go left or right, and I went 7 up. D is I went 2 to the right and I did not go up. Sorry, that's a parenthesis. E is four over and 6 down. F is 4 over and 2 up. G is 9 over and 5 up. Whenever you're given a graph and you have a list of points, this is a domino problem where if you don't list your points right, it may be difficult to get the next couple of questions. So now it's going to ask for the domain. Assuming that I did the points right, I'm going to list my x values in the order from least to greatest. -3, -2, 0, 2, 4, and 9. And my x values are the first ones. And then my range, I'm going to list from least to greatest, is -6, -5, 0, 2, 4, 5, and 7. The next thing it asks is if it's a function. Anytime I have a picture, it is easy to tell if something is a function by a picture. I'm going to use what's called the vertical line test, and I'm going to look at any point that is violating a function. So if you see A, there's nothing above or below A, and B also, and C, and D. But you see E and F, where if you draw a vertical line, or I put my pencil, it covers both of the points and they are both on here. That means it fails the vertical line test. So that would be a no. And what would make it a function? Well, I could do a couple of things. I could move him over a little bit. I could move him to the left a little bit. I could get rid of him. Anything to make sure that I don't have a 4 here and a 4 here. So here's the f of 2. Well, what's x when f is 2? I go up here and I see that there's the 2 in the x. So this is 0. F of negative 3. I see negative 3 right there, so that is 4. Now I say f of x equals 7, which means I'm looking for the y in the 7. So x is 0. F of x is negative 6. So y is negative 6. What's x? Y is negative 6. X is 4. Oops. X is, can't find my pencil, 4. Okay, find the domain and the range. When you are finding the domain and the range, look at your points and label your points. So I'm going to do my points as this point is negative 6, 6. And this point is 8, comma, negative 2. Okay, domain means x. I will start always with this annotation. And then I'm going to see how far to the left does this graph reach, and it reaches at negative 6. It's like I'm building a picture frame. But at my negative 6, I have a closed dot. Color means line. And then I come over here, so I drew this part of the picture frame. And then I come over here, and the x value is 8. No color, no line. Gonna do the same thing for the range. My range is always including y. I'm going from bottom to top. My bottom is at negative 2. No color, no line. My top is at 6. Color means I have to include that point. This concludes the 4-3 revisiting functions.